Assalamualaikum and hello to all. Today we are going to learn the third topic of this chapter, which is the elements of machine design. The principle of machine design in mechanical engineering covers three fundamental elements. They are mechanical behavior, machine elements, and manufacturing processes, which we have been introduced to in lesson 7. So now, we will start with the basic element of mechanical behavior first, followed by the others. Upon completion of this lesson, students should be able to identify the design process concerning with mechanical behavior of machine design. Any form of design is a decision-making process. The design process involves developing a plan to meet a need or solve a problem. For example, if you are designing something as simple as a chair, some of the things you will need to consider are the type of chair. For example, either it is an easy chair, an office chair, or a chair for a dining room table. Second is the person using the chair. For example, is it an adult or a child that is going to use the chair? The material used in the construction of the chair, like wood, metal, plastic, or a combination of materials. The strength and cost of the material used to make the chair are one of the things to consider. Another consideration is the shape and artistic appeal of the chair. In this section, we are concerned with the elements of machine design. In mechanical engineering, a machine is any mechanical system that transforms or transmits energy to do useful work. Whether you are a mechanical engineering student or simply an entrepreneur student brushing up on your technical knowledge, it is important to understand the mechanical behavior or mechanical properties that define the elastic or inelastic characteristics of different materials. The ability to classify and identify behavior materials is crucial in the manufacturing industry. It helps you quickly choose the best materials for your design based on various factors including load capacity, elasticity, hardness, strength, and much more. There are 19 mechanical properties that you should know that make each material unique. By becoming familiar with these terms, you will be able to differentiate between materials and assess their usefulness for your design project. So let's take a look one by one. So first is strength. Strength is the measurement of how much load a material can withstand before failure. The more load a material can bear, the more strength it has. There are 3 different types of strength based on loading types, which are compressive strength, shear strength, tensile strength. In regards to deformation before fracture, the 3 types of strength are elastic strength, ultimate strength, yield strength. The second one is fatigue strength. Fatigue strength is also known as the amount of cycles a material can withstand under fluctuating stress, like cyclic loading upon reaching failure. Fatigue refers to the failure of a material under cyclic loading prior to reaching its ultimate limit. The third one is brittleness. Brittleness is when a material breaks suddenly under stress without exhibiting much elastic deformation or changes in dimension. While the fourth one is stiffness. Stiffness is a material's ability to resist significant elastic deformation while loading. The less deformation a material exhibits during loading, the stiffer it is. Hardness is defined by a material's ability to resist various forms of deformation, indentation, and penetration. Hardness also refers to its resistance to scratching, scraping, drilling, chipping, and wear and tear. Next is toughness. Toughness is defined by the material's capacity to withstand elastic and plastic deformation without failure. Toughness is typically measured by the amount of energy a material can absorb before fracturing. Then embrittlement. Embrittlement is the result of metal losing its ductility and becoming brittle due to chemical or physical changes. While a mechanical behavior, which is homogeneity, is any material that has the same properties throughout its entire geometry. A homogeneous material cannot be mechanically separated or identified individually. Certain types of homogeneous material includes plastics, metals, glass, paper, resins, and coatings. Next is isotropy. Isotropy is often confused with homogeneity. Isotropic materials exhibit the same properties in any direction or orientation, whereas homogeneous materials have the same properties regardless of direction. Opposite isotropy, we have anisotropy. Anisotropy is a material that exhibits different properties based on its direction or orientation. For example, in computer graphics, an isotropic surface changes in appearance depending on the angle it's being displayed at. The following is elasticity. Elasticity is the mechanical behavior of materials that rebound back to their original dimensions after deformation or being removed from its load. Every material has a certain elastic limit before becoming deformed permanently, otherwise known as plastic deformation. While plasticity is a type of permanent deformation that occurs under stress before resulting in failure. Plasticity is commonly used in metal shaping to achieve certain shapes and forms. Ductility is the result of solid material becoming stretched due to tensile stress. A common application of this process is turning metal into wiring. While malleability here is mechanical behavior that has the ability to plastically deform a material or significantly change its shape without becoming fractured. Then we have machinability, mechanical behavior, which is the ease of which a metal part can be cut without sacrificing the quality of the finish. Creep is a slow and gradual deformation or change in dimensions of materials under a certain applied load. Creep can be measured by the influence of time and temperature. Creep is typically occurs at high temperatures, but can also occur at room temperature. Resilience is the ability to absorb energy while being elastically deformed and releasing that energy after being unloaded. The proof of resilience is the maximum amount of energy a material can absorb before permanent deformation. Damping refers to dissipating the amount of energy used to create vibration, oscillation, or stress. A material with a good damping property, such as cast iron, is capable of absorbing high amounts of vibration. And last but not least is the thermal expansion. Thermal expansion is a change in shape, volume, or area caused by changes in temperature. The coefficient of thermal expansion refers to the amount of material's shape or size that will change during exposure to a change in temperature. When engineers select the materials that are to be used in the machines and parts they design, they need to know how these materials behave under reasonable operating conditions. The criterion to be optimized when choosing materials for an engineering application might be cost, weight, performance, or some index, such as minimizing weight and cost with a requirement of a particular strength. The particular strength can be regarded as the constraints, also can be called as design requirements, which typically involve such mechanical behaviors like elastic modulus, means the stiffness, elastic limit, yield strength, and toughness. These mechanical behaviors can be expressed as engineering variables. Those variables must, in turn, contain the appropriate numbers and correct units. A design engineer must be able to define material requirements. Second, they need to understand classes of materials, such as metals and polymers. Other than that, they need to understand the internal microstructure of materials, which can be a crystalline or amorphous. They also must be able to use stress-strain diagrams to express materials' properties in terms of 5 engineering variables, which are stress, strain, elastic limit, yield strength, and toughness. And finally, use the results determined for those variables to carry out materials selection. For example, if a child drops a plastic toy onto the floor, the impact should leave the toy looking like it did before it was dropped. As the toy's designer, how do you choose a plastic that is tough enough to survive a child's play, but not so expensive as to be unaffordable? So this is among the common and logical questions raised in the mind of a designer to supercharge their reasoning skills. That's the end for this section. In next lesson, we will continue to explore the basic of machine elements for the principle of machine design in mechanical engineering. Thank you and Assalamualaikum.